Hi there, and welcome back to my channel. Today, I want to discuss with you how to convert your project using controllers to using minimal APIs, how to add versioning, Swashbuckle, and then finally to test it using K6 to see how much of a performance improvement you've gained. So getting started, let's go through the project itself. We've got two solution folders, source and test. Inside that, we've got the minimal APIs tutorial and the minimal APIs tutorial.tests. We've got a bookings controller, we've got booking as a model, and then we finally got a repository which is split with an interface, and the bookings repository itself. You'll see in the bookings repository, we aren't doing much. In fact, we're actually just using await task completed task. And in the bookings controller, we have CRUD functionality. So we've got a create booking, update booking, delete booking, get booking by ID, and get all bookings. In the program file, we have Swagger implementation, and we've added the repository to the program. Now, if we run the application, we'll see that we have Swagger documentation for those endpoints. Back in the code, let's remove the controllers from our program file. Next, we're going to add a simple Hello World endpoint, and we've called it Hello World, and the response being Hello World. The next thing we'll need to do to wire this up is add endpoints API Explorer. And if we run the application again, we'll see that we have a new endpoint. And that's exactly what we can see. It's quite easy to add minimal APIs. However, as you can imagine, this would become difficult to manage once you start adding a lot of endpoints into the program file. One of the benefits of controllers was that we had a separation between the controllers and our program. So of course you can add your minimal APIs into the program file, and you can also add slices. However, today, what I wanted to show you is how to have a very similar approach to controllers, something you're probably quite used to, but then also gain the performance benefits. So we'll delete this map get and we'll create a new folder called endpoints. Inside that folder, we're going to add a new helper function, and that helper function will be endpoint group base. Here we've made endpoint group base abstract, and we've got an abstract method called map. This will be used by our bookings endpoint later on. The next thing we're going to do is add some extensions just to make the process a little bit simpler. And then we're going to add endpoint route builder extensions. Here what we've done is we've defined our own version of the map get, map post, map put, and map delete. And the reason we've done that is so we can add some basic configuration to them. So in this case, we've added the name and we've added the specific type that we want to add. The next extensions method we're going to add is web application extensions. And here we're going to use the endpoint group base that we've just created, and we're going to port in its dependencies. Here, you may have noticed that I've got with group name commented out. The reason for this is because in a lot of tutorials you may see online, with group name is added. However, this will actually break Swagger implementation if you're using Swashbuckle. So that's something to keep in mind. The reason for that is because it hasn't been updated in a few years. And so Microsoft is looking into upgrading this into their own library in .NET 9. So I'll delete that for now. And then we can get started creating the bookings endpoints. Here, what I've done is I've just pasted in all the endpoints, and we can describe what's going on as we go through them. So first up here, we can see that we're extending from the endpoint group base that we created before. And then we're implementing the map method by using the override keyword. The next thing we're doing is we're creating a group, this being the group, and then we're adding the specific name that we want for our endpoints. So for get all bookings, that of course is a get bookings by ID, also a get, map post for the create, map put for the update, and map delete for the delete. Next, you can see that we've pulled across the XML summaries. This will be useful later on in Swagger. And the next thing is, instead of using iResult, we're using results, and we're passing in the specific HTTP response that we want directly. In this example, we have two specific options. We have OK, which returns a booking object, or we have not found. To use this type safety, we need to use type to results, .ok, and not results, as this will cause an exception. The reason you would want to use type to results instead of results in general is because then you have the full type safety, and you can use this for your testing later on. Next, in the create booking, it's a very similar example. We have type results.created, and we're returning that object. In the update booking, we're returning no content, and in delete booking, we're returning no content. One thing you may have noticed is that we're not using MVC. Since we're using minimal APIs, we don't need to use MVC anymore. This is the same for our problem details exceptions, though in this example, we're not using them. To wire all this up, we need to go back into web application extensions, and we're going to create a new helper function called map endpoints. As you can imagine, this is very similar to the map controllers that we previously had that Microsoft built for us. However, in this situation, we're actually going to create them ourselves, as this is more performant. Of course, we can use reflection to make the process simpler in case you, for example, don't want to have to remember to add the booking endpoints and other endpoints. However, for the most performant solution, I suggest adding it directly. So you can see the difference between reflection and non-reflection. I'll add the other below. But of course, it's not going to be used as we already returned the app. Then of course, we need to use the map endpoints method. So we go back into program, and where we used to use app.mapControllers, we instead will use app.mapEndpoints. If we now rerun the application, we can see all the endpoints are back. However, what you may have noticed is that we don't have any of the XML summaries. So let's go ahead and fix that. To add XML summaries into your Swagger docs, it's a very similar process to what you would do with controllers. Inside @swaggergen, we get the name of the XML file, and then we include XML comments. Next, in the CS project file, we need to add the following line, generate documentation file, and we set that to true. Now, if we rerun the application, we can see that we have the XML comments alongside our endpoints. If we go to our put, we can also see that we have both 200 and 400. So everything's working quite nicely. Next, you might be thinking, how do we add versioning? Back in the code, we're going to stop the application and we're going to add a new package to add versioning into our project. The dependency we need to add is not an official Microsoft dependency. However, it is widely used and it has a lot of contributors online. This package is called asp.versioning.http, and to implement it into our codebase, we just have to go back into the program file and we need to add something into add_swaggergen. That thing being doc inclusion predicate. What this will do is we're going to replace the version API-version with the version that we're getting. But you might be asking, we don't have the API-version yet. Well, let's go add that. So back in the web application extensions, we're going to change the map group to /API/v, and then we're going to add API-version/group name. This will ensure that we add the API version to those endpoints. Back in the program file, we need to add one more piece of infrastructure. Here, we're going to add API versioning, and we're going to set the default API version to API version default, which in this case will be 1. And if we run the application one more time, we can now see that the version has been added into the paths of our endpoints. Back in the source code, we're going to stop the application and we're going to start doing some K6 testing. If you're unfamiliar with K6, K6 is a great tool that you can use to do load testing and spike testing. If you don't have it already, inside the terminal, you can type brew install K6. I already have K6 installed, so I'm going to skip this step. To give both controllers and minimal APIs a fair go, what we're going to do is we're going to remove the versioning that we just added. Next, we need to go back into the web application extension, and we'll also need to revert our changes to the map group prefix. Going back to the program file, we're going to comment out map endpoints, and we're also going to comment out add endpoints API Explorer. We're going to add back add controllers. We're going to add back map controllers, and we're also going to add back map default controller route. Next, we're going to create a new file, and that file is going to be called spiketest.javascript. Next, I'll paste in the code, and here what we've got is a basic spike test using K6. We've added the check and fail to validate if the endpoint is passing or not. We add the scenario that we want to test. We add the views, we add the duration, and we add this threshold. This threshold means that 95 requests should be below 900 milliseconds. In the test itself, we're using the get endpoint. We're checking if it's okay or not, and that's it. We're next going to start the application, making sure that we use the HTTPS version. And now that's running, we're going to go back into the terminal and we're going to run that test. And we have 100,000 requests that we want to make. So I'm going to start it now and I'll pause the video until it's done. Okay, and we're back. Now let's look at the results. So here the results show that it took 2 minutes and 14 seconds to run through all 100,000 of the records. Now let's test it with minimal APIs. So first we go back to the program file. We of course stop the application. We add back the endpoints while we're removing the controllers. We'll restart the application, and now we'll run the test again. I'll again pause the video until we are ready to look at the results. And we're back. So the results of the minimal APIs was that it took exactly 2 minutes to run through all 100,000 requests. If we do a calculation of those results, that gives us a 6.25% improvement. Of course, these results can vary, and depending on your application, it might be more or it might be less. However, that gives us good indication that minimal APIs are indeed faster. Thanks for watching. If you enjoyed what you watched today, please like and subscribe, and I'll see you for the next video.